Welcome to This Explainer. Today, we're diving into exactly why your brain plays tricks on you. And to do that, we're actually going to start with a fascinating, kind of mind-bending mystery that dates back roughly 150 years. We walk around every single day just assuming the world we see in front of us is the absolute objective truth. We trust our eyes implicitly. But, as we're about to uncover, your reality might just be a very, very convincing real-time illusion, one that's custom-built by your own biology and your environment.
So what do you see here? This is a classic illustration from the mid-1800s by the American psychologist Joseph Jastrow. What immediately jumps out at you? Just take a really good look. What kind of animal is that?
Well, some of you probably instantly saw a duck looking off to the left, right? While others definitely saw a rabbit facing to the right. But here's the real catch. You cannot see both of them at the exact same time. The image itself allows for both interpretations, sure, but switching between the duck and the rabbit actually takes conscious mental effort. You literally have to force your brain to reinterpret those lines and curves. It's like a mental tug-of-war.
And this brings up a truly fascinating, almost existential question. Philosophers and cognitive scientists often call this the problem of qualia, which is really just a fancy term for the subjective, conscious experience of a sensation. When you and I look at the color orange, or when we look at this drawing, do we actually experience the exact same hue? Do we share the exact same illusion? Think about it. If we can't even agree on whether a few simple lines make a duck or a rabbit, do we really experience the exact same reality?
Part 1. The biology of an illusion. How physical brain size alters subjective perception.
Okay, so to really understand these subjective differences, we have to look at the hard biological science, because it turns out the way you see the world is deeply rooted in the physical structure of your brain. In one study, using the famous Ebbinghaus illusion, where you have two central circles, one surrounded by giant shapes and the other by tiny ones, researchers asked people to judge which inner circle was larger. And the thing is, even if you logically know those two center circles are perfectly identical in size, your brain absolutely insists one is bigger. It's wild.
To figure out why our brains glitch like this, researchers didn't just hand out questionnaires. They went straight to the source. They used fMRI to map the participants' visual cortex. That's the specific region at the back of your brain responsible for processing visual information. By measuring the physical volume and the neural activity of this area across different people, they were hunting for a structural reason behind our visual blind spots. And when they reviewed those fMRI results, a fascinating direct correlation popped up. People with a physically larger visual cortex were actually significantly better at judging the true size of the inner circle. On the flip side, those with a smaller visual cortex were the least accurate, meaning they were way more easily fooled. And researchers found this exact same pattern using multiple different illusions. Your physical biology literally dictates how easily you're tricked.
So why does physical size matter here? Well, scientists suspect this vulnerability to illusions is heavily tied to chemical messengers, specifically the concentration of things like GABA neurotransmitters inside the visual cortex. GABA is basically an inhibitory messenger. It helps quiet down surrounding neural noise, kind of like turning down the background chatter at a loud party. So the working theory is that a larger visual cortex might just have a different distribution of these chemicals, and that allows the brain to successfully suppress misleading context, like those big deceptive outer circles, and just focus on the true size of the object right in front of it.
Part 2. The context of perception. Seeing the world through different lenses.
But here's the thing. Biology is just one lens. Other studies reveal that neurodivergent factors, like autism, can profoundly change how intensely an illusion is experienced. Individuals on the autism spectrum often process visual details more accurately, which actually makes them less susceptible to certain broad-stroke optical illusions. And get this, culture plays a massive role too. Researchers have found that people from heavily carpentered urban cultures, environments packed with straight lines and sharp right angles, experience geometric illusions entirely differently than people from rural, uncarpentered environments. Your background is actively shaping your visual reality.
You see, you don't just passively capture a scene like a video camera recording to a hard drive. Your brain is aggressively constructing that image in real time. It's constantly pulling from a massive database of immediate context, past experiences, and environmental clues just to make an educated guess about what's actually out there.
I absolutely love this example of how powerful that contextual database really is. Researchers went back to that Jastrow duck-rabbit drawing we looked at earlier. They found that when children were shown the illusion on Easter Sunday, a time when rabbits are literally everywhere in the culture, way more kids naturally saw the rabbit. But on a regular, non-holiday Sunday, they were more likely to see the duck. The environment primed their brains. And honestly, if you were to show it to them in late November, they might even view the duck through the lens of turkey season. The literal time of year is dictating what their brains decide to see.
So the crucial takeaway here is that our perception is continuously being filtered. Whether we're trying to judge the size of geometric circles, looking at a drawing of a duck, or perceiving dolphins splashing out of some abstract lines, what you are seeing is never raw, unfiltered data. It's always a highly complex, instantaneous interpretation.
And this absolutely shatters that old saying, right? We've all heard the phrase, what you see is what you get. But as this explainer proves, we basically need to cross that out entirely. The real truth is, what you see is perceived through different lenses. Your visual cortex size, your chemical messengers, your cultural background, and yep, even the time of year. They all pile up like heavy, heavy filters on a camera lens, deeply altering the final picture that your mind develops.
So, as we wrap up this explainer, I want to leave you with a lingering thought to ponder. If even the physical size of a simple circle on a piece of paper is entirely subjective and completely dependent on the millimeter size of your visual cortex, what else in your daily life is just a construction of your own mind? If you can't always trust your own eyes, what other parts of your reality are just a trick of your personal lenses? Definitely think about that the next time you're absolutely certain of what you just saw.